Hey there, Pixelers, it's Michael Haddon. Large language models are revolutionizing the tech world as we know it. In this episode, we're going to embark on an exciting journey, merging LLMs with Kubernetes to create an easily maintainable system aimed at slashing recovery time to the bare minimum. Outages can be complex, however, with a little AI goblin in your cluster, he can soothe your nerves and help resolve all sorts of issues. LocalAI is at the heart of this whole thing. It is a brilliant drop-in replacement of OpenAI, allowing you to run models locally or on-premise, even with consumer-grade hardware. This powerful feature opens up new possibilities for AI integration across a large range of applications. LocalAI is versatile, working with a variety of models like llama-based GPT4ALL, RWKV, and GGML. You can head over to Hugging Face to find the perfect model for your unique needs. Today we'll be exploring two models from GPT4ALL, the commercially licensable Groovy and the llama-based Snoozy model, which isn't commercially licensable but promises oodles of fun. Alright, enough chit-chat, let's get our goblin up and running. First, we'll clone the LocalAI repository, then download the GPT model we fancy, starting with the commercially viable one. Once it's in our models folder, give it a few minutes, we'll copy our prompt template there too. This is important. If you do not do this, you'll get gibberish responses. We can then quickly set the number of threads and we are off. Let's fire up Docker Compose and get this party started. Give it a few minutes to build and run the server. Then we can query the API for available models, chat, or message completions. The best part? Since this API is a perfect match for the OpenAI API, custom ChatGPT apps can easily link up for a silky smooth chat experience. Feast your eyes on these responses. It's always a treat when things just work. But ask the model what is Kubernetes and brace yourselves for some bizarre responses about Turkish cuisine or Icelandic traditions. Time to be amazed by the GPT4ALL Snoozy model based on Meta's incredible Llama model. This gem of a model shines when it comes to dishing out valuable information. However, do keep in mind that as it's based off the Llama model, it's not suitable for commercial use. But don't lose hope. With the recent release of OpenLlama project, which permits commercial licensing of its data, things could change soon. For now, let's switch gears, stop our Docker server, and dive into the world of the snoozing model for GPT4ALL. Don't forget to create a new fantastic template for this new model. Once you're all set, watch as the API delivers spot-on responses to your queries, making you wonder how you ever lived without it. We're about to integrate LocalAI with Kubernetes, and what's more, we're actually going to run a LocalAI inside of Kubernetes too. We'll kick things off by creating a local Kubernetes cluster using the brilliant K3D tool. K3D works its magic using K3s, a nifty lightweight version of Kubernetes that packs all the punch we need. Our nodes will run as Docker containers, cleverly mimicking a real cluster without any of the overhead. Once Kubernetes initializes, we'll install the Helm chart for the K8sGPT operator. K8sGPT is a game changer as it scans your Kubernetes clusters, diagnosing and triaging issues in plain English. The operator creates report results, saved right inside the cluster as a new shiny results resource. First, we'll integrate it with OpenAI to showcase its functionality. Then, we'll look at installing LocalAI into the cluster and integrating it with our model. Let's start by creating a quick secret containing our OpenAI API key. Next, we'll create a new K8sGPT resource that connects the OpenAI API and processes error messages. Oh, and can't forget to run a cheeky broken kubectl command to a non-existent Docker container. This will be our fun dummy error. Give it a moment, and you'll see a results resource being created. It's packed with helpful tips and tricks on how to resolve our error. It might not be perfect advice, but it's a lifesaver for anyone with less experience. I'm excited to see the future where we can fine-tune a model to understand the full cluster and codebase to give more accurate and surgical advice. Let's bring together the two awesome things we've just explored and run K8sGPT in Kubernetes using LocalAI as its backend. First, we'll delete our K8sGPT resource to avoid any unwanted interactions with OpenAI. Next, we'll create a new config map which will hold our template, that we've been previously copying around to structure queries for our model. Now, it's time for a new deployment. This deployment will create a pod with an init container that will download our model. Our pod's main container will be LocalAI, and it will mount our template from the config map. To wrap it up, we'll create a service for K8sGPT to connect to. By port forwarding our new pod, we can query the API and confirm everything's up and running. Finally, we'll create a new K8sGPT resource, point its backend to LocalAI, specify our model, and wait for the magic to happen. As expected, we receive a super helpful and useful new result resource. K8sGPT and LocalAI united at last. We can tweak our prompt template to perfectly suit our model's queries to our context. By rewriting the prompt to explicitly state the context for the model's queries, our responses will always be customized to that context. Let's give our context a little makeover. The prompt below is an error message from inside a Kubernetes cluster. Create a list of possible solutions and actions a software engineer could take to diagnose and resolve the issue. Now we can throw anything at the API like out of memory, and it'll know that the error must be related to Kubernetes. You could imagine all sorts of meta information you could pass into this prompt template to further enhance the responses you get. The world of engineering is evolving at breakneck speed. With large language models, we can simplify our administration skills and conquer all sorts of challenges. Imagine harnessing the power of LLMs for system alerts from Prometheus or other monitoring suites. When we can embed the full scope of our organization's projects into these models, there's no doubt that they'll become an indispensable tool in every system. Imagine asking the system in plain text how a tool or service operates and getting a detailed and useful response. Maybe humanity will be able to finally make sense of sprawling microservice architectures. Thanks for checking out this video. As always, I hope you guys have a lovely day. Cheers.